There was a time when the strip of foil you used to wrap your lunch sandwich was worth more than gold. There was a French emperor who threw banquets where his most honored guests ate with aluminum forks, while the rest had to settle for gold. The story behind that everyday metal in your kitchen is far stranger than you think, and 99% of your friends have no idea.
Welcome to Secrets of Everyday Things, the channel where everyday secrets are uncovered and explained.
Take a quick look around. The Coca-Cola can on your desk, the roll of Reynolds wrap in your kitchen drawer, the case of the phone in your pocket, the sliding window frames in your house, the rims of the old Schwinn bike you used to ride around the block as a kid, the body of the Boeing that flies you home for Thanksgiving. Aluminum is everywhere. It is light, strong, rust-resistant, and easy to shape. It is the signature metal of the 20th and 21st centuries. But here's the strange part. Aluminum almost never shows up in nature as a shiny metal. It hides in the ground, dressed up as a reddish clay that looks just like the dirt in your backyard after a rainstorm. So that cold soda can in your hand was, not so long ago, basically a chunk of red mud. So how did we turn red mud into a metal that can fly? This story has a flashy emperor, two scrappy 22-year-old college kids, a backyard woodshed in Ohio, and an electric current so strong it can make the coins in your pocket dance across the floor. Settle in, because today on Secrets of Everyday Things, we are going to tell you about the most ordinary metal with the most extraordinary story. Step back to the early 1800s. Scientists in Europe knew that something called aluminum existed in nature, but they could not pull it out as a pure metal. Aluminum clings to oxygen like superglue, and every attempt to break that bond came up short. In 1825, the Danish scientist Hans Christian Ørsted produced a tiny bit of aluminum, just enough to be called a sample. A pinch, really, not even enough to make a teaspoon. For decades after that, aluminum stayed one of the rarest, most expensive metals on the planet, dearer than silver and at moments dearer than gold itself. How expensive? Expensive enough that Emperor Napoleon III of France used it to flex on his guests in the most bizarre way you can imagine. In the 1850s, Napoleon III was throwing some of the fanciest dinner parties in Europe. At his table, there was an unwritten rule. The most important guests, the ones he wanted to impress, ate with aluminum forks and knives. Everyone else ate with gold. Yes, gold was the lower-tier flatware. Why? Because at the time, an ounce of aluminum cost twice as much as an ounce of silver, and the entire planet only produced a few kilograms of it each year. Owning some was the ultimate flex. Napoleon even daydreamed about aluminum armor and aluminum buttons for his soldiers, since a lighter army would march faster and fight harder. Sadly for him, the price tag never let that dream come true. Across the Atlantic in Washington, D.C., the United States government was wrestling with the same problem. They wanted to finish the Washington Monument, the tallest stone tower in the world at that point. And they needed a special tip that could serve as a lightning rod and stand as a symbol of national greatness. They picked aluminum. In 1884, they cast a tiny pyramid almost 9 inches tall, weighing exactly 100 ounces. It was the largest single piece of aluminum ever cast at that time. Before they bolted it to the top of the monument, they put it on display at Tiffany's in New York City. New Yorkers stood in line for the chance to step over it, just so they could later brag to their grandkids that they had stood on top of the Washington Monument. An ounce of aluminum back then cost about a full day's wage for the laborers building that very monument. Think about that. To buy a piece of aluminum the size of your fingertip, a working man had to put in a full day under the hot sun. The cheapest metal in your kitchen today was once the ultimate luxury good. Then something almost unbelievable happened. In 1886, just 2 years after that aluminum cap went up, two young men on two different continents, who had never heard of each other, both cracked the code at the same time. They were even born in the same year, died in the same year, and discovered the very same process within a few months of each other. Can you wrap your head around that? One was Charles Martin Hall, a 22-year-old fresh out of Oberlin College in Ohio. Hall had no fancy lab. He built himself a little woodshed behind his parents' house, hand-cranked his own batteries, brewed his own chemicals, and got help from his sister Julia when he could. On February 23, 1886, in that tiny woodshed, Hall ran an electric current through aluminum oxide dissolved in molten cryolite, and out came pure aluminum. Meanwhile, in France, Hall-Heroult, also 22, was doing the exact same thing in his own lab. Both men were born in 1863. Both died in 1914, and they accidentally changed the world together without ever meeting in person. The Hall-Heroult process, named for both men to be fair, sent the price of aluminum into free fall. From rarer than gold, aluminum lost roughly 200 times its value in just a few years. The first plant to use it was built right next to Niagara Falls, and it dropped the price first to 75 cents a pound, then to 30 cents. A metal once reserved for emperors suddenly cost about the same as iron, and the entire industrial future of the world shifted with it. If your grandparents ever told you stories about World War II, about the B-29 bombers darkening the skies, about every American family donating their pots and pans during the great aluminum drives so the metal could be melted down for warplanes, that whole chapter started in an Ohio woodshed in 1886. So back to the original question. How do we actually go from red dirt to a Coca-Cola can? The process is wild. It all starts in tropical regions where the soil is full of aluminum, in an ore called bauxite. Today, Guinea in West Africa holds the largest known reserves at about 7.4 billion tons. Australia and China lead the world in mining it. Giant earth movers scrape away the topsoil and haul the bauxite back to refineries. But this stuff is not aluminum yet. It only contains aluminum, mixed with iron, silica, and a long list of other impurities. The ore is crushed and dumped into a hot bath of sodium hydroxide. This is called the Bayer process, named after Austrian chemist Karl Bayer. The aluminum dissolves into the solution, while the iron and silica sink to the bottom as a thick, red sludge. Every single ton of finished aluminum leaves behind up to 4 tons of toxic red mud. And this is one of the biggest environmental challenges in the entire industry. Red mud is highly alkaline, very salty, and if a holding dam ever breaks, it can bury entire villages. Researchers in Australia are now experimenting with ways to turn red mud into farmable soil within just 2 or 3 years. The story is still being written. Once the aluminum is in solution, the liquid cools and tiny crystals of alumina start to form. Heat them to drive off the moisture, and you end up with a fine white powder that looks just like table sugar. That powder is alumina, or aluminum oxide, but it still is not metal. The bond between aluminum and oxygen inside that powder is so stubborn that no normal kind of heat can break it. This is where the Hall-Heroult process steps onto the stage. The alumina is dissolved in molten cryolite, poured into a giant carbon-lined tank, and a massive electric current is shoved through it. The current in those tanks is so insane that if you stand close to one, the loose change in your pocket actually slides across the floor on its own. Your credit cards get wiped clean, and any nearby nuts and bolts clump together like magnets. That is a real story from a worker who used to run those plants, not science fiction. The current rips the aluminum atoms away from the oxygen. The oxygen rises and combines with the carbon to form carbon dioxide, while the pure liquid aluminum, glossy and silver, settles at the bottom of the tank. They siphon it off, pour it into molds, let it cool, and you have shiny, clean aluminum bars weighing tons. This whole show eats electricity for breakfast. That is why aluminum smelters are almost always built next to hydroelectric dams. The old Niagara plant, the smelters in Quebec, Iceland, and Washington State, all of them sit right on top of cheap, abundant power. Making 1 fresh pound of aluminum from ore burns more electricity than running your refrigerator non-stop for a week. And here is where the magic kicks in. Aluminum is one of the only metals on Earth you can recycle almost forever without losing any quality. You toss a half-empty Coke can into the blue bin in your garage on Friday night. It gets picked up Saturday morning, melted down, rolled out, stamped into a fresh can, packed, and shipped. The whole loop only takes about 60 days. That means the can you tossed today could be back on the shelf at Walmart in 2 months. Even better, recycling aluminum uses only about 5% of the energy needed to make it from scratch. In other words, every can you toss into recycling saves enough power to run your TV for about 3 hours. If you ever sat in front of the Super Bowl with a dozen empties on the coffee table, just imagine that whole stack, recycled, could power your entire game night. This might be my favorite part of the aluminum story. When the Wright brothers built their first plane in 1903, they wrote letters to every engine maker in America, asking who could build them a motor light enough to actually fly. Nobody could. So they turned to their own shop mechanic, Charlie Taylor, and Taylor cast the engine block out of aluminum. That was the very first time aluminum was ever used in an aircraft engine. And today, nearly every plane in the sky owes its lineage to that little engine. The next time you take that flight from Chicago down to Florida to visit your folks, remember you are riding inside a frame born out of red dirt from West Africa. Aluminum has also stitched itself into the memory of an entire generation of Americans. It is the roll of Reynolds wrap your mom used to wrap baked potatoes on a Sunday night. It is the Swanson TV dinner tray your family balanced on their laps in the 60s and 70s while the Ed Sullivan Show was on. It is Grandma's shiny aluminum kettle whistling on the gas stove. It is the Pan Am jetliner that carried your dad to a business trip. It is the sliding window frame in your childhood bedroom, the rim of the Schwinn bike you rode every summer evening, the Schlitz can your father held during Monday Night Football. One simple material, woven into almost every memorable moment of our lives. Next time you tear off a piece of foil to wrap half a sandwich for your kid's lunchbox, pause for 1 second. That flimsy strip is made of the same atoms as the cap on the Washington Monument back in 1884. The same atoms Napoleon III used to flex on his royal guests. The same atoms Charles Martin Hall sweated to extract in a backyard woodshed in 1886. The same atoms flying high in the body of a Boeing 747, carrying your family on vacation. And right now, those atoms are sitting in your hand, ready to wrap tomorrow's lunch. We have gone from treating aluminum like treasure to using it to wrap leftovers. That is progress you can literally hold in your hand. Next time you open that drawer and see the foil, you will know a story that 99% of your friends do not. And maybe you will pass it on to the grandkids sitting next to you. That is the story of aluminum. Something that looks simple, but turns out to be wonderfully strange. A small piece of metal in your kitchen carries 200 years of science, industry, and human emotion. What other ordinary thing in your house do you suspect has a hidden story behind it? Drop a comment and we will dig into it together in the next video. Because the simplest things, it turns out, are the most extraordinary of all.